Oh, okay, thank you. Okay, so we're gonna. So is this sharing screen? Okay, so it's recording. Good. Okay, so some people ask me about this type of solution sets, and you guys need to watch the videos because you have no idea how to do some of these because probably you haven't seen my videos. So, for example, this one, letter A. So, what do you think is gonna be? No solutions, infinitely many solutions, unique solutions, none of the above. Somebody? Yeah, you guys probably better talk because I cannot be checking chat and so infinitely many solutions. Yes, B. Somebody said B. Infinitely many solutions because you go here, you go X, Y, and Z, right? And this is X, this is 0Y, and you have C. So you have well, oh no. No, maybe not. Let's do it. Let's do it. You have to do. But you better probably set it up, set the system of equations. Let me open my OneNote. You can do it. So we do OneNote. So the system is 10016 001 minus 12. So 10016 001 minus 12, right? That's what it is. 16 and minus 12, yeah. So from here you get X, Y, and Z. So you get X equals 16. And then you have Y zeros. And then you got Z equals minus 12. Oh, yeah. And then you see Y is whatever you want. So yeah, that's probably gonna be infinitely many solutions. Okay. So we can say probably infinitely many solutions. The next one, what do you guys say? For letter B. No solution. Yeah. For letter B, we have no solution. Because you have the third column is 001. So that's no solution. Okay, that's no solution. And then they just very similar, right? So this one, the third one, which will be no solution, no solutions. Because the last one, that last line is 0001. And then the D should be infinitely many solutions. Because it's 000, the last column. So I just check my Yeah. At least one of the answers not correct. Let's see which one. Show correct answers. No, this. So B, C, A. Oh, the last one. The last one is not correct. The last one we got. Oh, sorry. Yeah, the last one is. And the last one is. Oh, yeah. The last one is tricky. Well, not tricky, but so you have. Let's do the last one. 1 0 1 0 0 0 1 0, and then you got here 18 19 0. 18 19 0. So this exercise is good because it's X and Y, you see. So if I made that exercise, I get X equals 18, Y equals 19. So this last equation is X. That doesn't give me any information. So it's only one solution because I only have two variables. Okay. So that one is only unique solution. Yeah, now it's good. So you see those are kind of very similar. All the problems are going to be very similar. So all these problems are similar. So just have to choose. They're all similar now. Okay. So let me know you have other questions on homework. I extended for Wednesday. So you guys still have more time for Wednesday. Okay. So today, I think we're gonna do probably for today, I can open the new one, basis and dimension. Or linear independence. So linear independence and span. So I think these are the ones I'm gonna open today. So that's probably the problems you're gonna have for this week. Linear dependence and span. So that's what we're doing. Okay. These are gonna be the problems for this week. Okay, so let's finish. If there are no questions, let me check if there are questions. Oh, okay, quiz. My guys talk because I cannot be just checking my chat. You just should talk. So about the quiz. So yeah, so on Wednesday we're gonna do linear independence and the Gaussian elimination. Let me see. Let me see the problems we have. So it's gonna be over the homework we have already today, and whatever we can cover today. So I usually what I do is choose two problems out of these problems you have over here. Okay. So it's nothing too new. So that's something you already know what to solve. Okay, I'm not gonna come up with new problems. So those are problems that you have been solving in your homework. It's more like for me to see if you are really doing your homework or somebody's doing it for you. So you have been doing your homework, you should have no problem, right? So I'm gonna get it from the homework. So that's the plan.
Sir, can you go over problem 8 in types of solution sets?
Okay, so let's see. 8. Okay. So determine the value of h such that the matrix is the geometric matrix of a consistent linear system. Yeah, so you just play with that number. So let's do it. You just play with h like it's a number. 4 minus 5h minus 12, 15, 9. And at the end, you probably can get values. Just give a value to h, so everything works. So let me see. So is 4 minus 5 h minus 12, 15, 9. So you first divide by 4. So you got 1 minus 5 fourths, and then 8 fourths. You got minus 12, 15, and 9. Now you need to get a 0 over here. So you go row 2 is 12 times row 1 plus row 2. Minus 12 row 1 plus row 2. So then I get a 1, 0, and then this minus 5 fourths, and then 8 fourths. And then I get here 12 times minus 5 fourths plus 15. Okay, so 4, 1 is, here is 3. 3 minus 5 is minus 15. So minus 15 plus 15 is 0. Also, I get a 0 here. And then the next one is 12 times h fourths plus 9. So 4, 3, that will be 3h plus 9. And then 12 times h fourths plus 9, that's 3h plus 9, yeah. 3h plus 9. Okay, so what do you guys think? What should be a good h for this to be consistent? So we determine the value of h such the matrix is the geometric matrix of a consistent linear system. So consistent means it's gonna have at least one solution or infinitely many solutions. So what do you think? What could be h? I thought somebody wants in the chat. So let's say if I have 0, 0, what happens if I have a 5 here? Is consistent or not consistent? It has solutions or not?
You wouldn't have a solution.
No, I will have a solution. So when I'm gonna have a solution? Or infinitely many solutions? Infinitely many solution is infinite number of solutions. It just infinitely many is like the right way to say it, I guess. When this, what number should be here? For this to be consistent.
-3.
Yeah, -3 will be a good one because you have 3 times -3 plus 9. That will give you a 0. So that you will get, let me erase this for a second, you'll get 0, 0, and 0. So that's consistent because it has infinitely many solutions. And then h is equals 0, no, -3, yeah. So you will have to solve it, right? I think -3 could be the answer. Let's see. Yeah, this -3. So you just play with it. So just carry the letter and do some algebra, okay? Okay, so let's go now to the topic of today. Today's linear independence. So from the book already, well, I'm gonna define again linear independence. And we're gonna do one example. So let's remember what is linear independence. So we already said that if you have one vector here and there, two vectors, Are they linearly independent or not? These two vectors, are they linearly independent or not? So this is A. What about B? Are these two vectors linearly independent or not? What about C? So which of out of these three are linearly independent? Or which one is linearly dependent? So B is linearly dependent because it's in a line. These guys are not linearly dependent because I cannot set it up in one line, in the same line, okay? Just for curiosity, somebody's chatting. No, okay. So what does it mean to be like this? So let's say this is U and this is B. So they are linearly dependent, because probably B can be written as a constant times U. Okay, and that you could say B minus CU equals 0. So that's where the definition is coming out. Okay, so if you are in three-dimensional space and they are in the same plane, so they are linearly dependent. Okay, they're not independent. But if you put this one over here, this is out of the plane. So for one plane, you need two vectors, not three. And one outside will be linearly independent to the vectors on the plane, right? We already said that before. So, so definition. So write it down so you don't forget. Definition. Let U1, U2, UM be a set of vectors in Rn if the only solution to the vector equation x1 u1 plus x2 u2 plus xn un is 0 equals 0 is the trivial solution x1 equals x2 equals x3 and so on, xn equals to 0, then u1, u2 until un are linearly independent. Okay. So this is, this is the same that I said over here, but for several dimensions. See, you have xb, x1b plus x2u. If the only way that you can make this 0 is x1, x2 equals 0, they are linearly dependent. But suppose that you can make let's say minus 5 plus 3 equals to 0, then they are not linearly independent. Because if you solve it, you will be like minus 5b equals minus 3u, and then b equals 3/5 u. So they are basically in the same line, and this is just, you have to make one vector is smaller than the other one, okay? So I think geometrically it's easy to understand what is linearly dependent than independent. Geometrically, so if you read this definition looks ugly. It probably doesn't make too much sense. So, but that's the real definition. Okay, so let's do an example. So let's make an example from the book. You guys can compare how the book does it and how do I do it. Now this is pretty much all the same now. So determine if, oh, but this is kind of long. Well, let's do it. Determine if the set u1 equals minus 1, 4, minus 2, minus 3, u2, these are vectors, no? 3 minus 13, 7, and 7, and u3 equals minus 2, 1, 9, and minus 5, right? Is linearly dependent or linearly independent? So what you need to do is set up x1 u1 plus x2 u2 plus x3 u3 equals to 0. And simplify the system and see if you can find a solution. So you can find x1, x2, x3 that make this equals to 0, then they are not linearly independent. If x1, x2, x3 are gonna be 0, they are linearly independent. Okay, so we put this in a system. This looks like what? Like minus x1, but yeah, I don't need. No, let's put it for completion. Let's put it like plus 3x1. Oh, no, sorry, I'm doing it wrong. Now let's put it like just put it on the matrices already. So this is gonna be x1 over here, this is gonna be x2 over here, and there's gonna be x3 over here, and then you're gonna have 0, 0, 0. So it's like solving a system, but v is just 0, so it's even easier. Okay, so this is minus 1, 4, minus 2, minus 3, 3, minus 13, 7, and 7. Minus 1, 4, minus 2, minus 3, 3 minus 13, 7, and 7, and minus 2, 1, 9, and minus 5. I'm missing a 0 here. So this is 0. So the same than always, we need to try to put zeros, 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 and so on, right? So so what should we do? So I guess Just to multiply the first one time minus 1, just because we usually look like that. 1 minus 3 and plus 2, 0. And the book does it different, so I want to do it different. So, well, the book doesn't do all the details, so I want to do. I don't like when the book doesn't do all the details because I don't know how long it's gonna be. But let's do it then. So this might be long. Let's see. So row 2 is gonna be minus 4 times row 1 plus row 2. Minus 4 row 1, yeah, so that'll be 1 minus 3, 2, 0. And then we got minus 4, round 1 is 0. And then minus 4 times minus 3 is 12. Minus 13 is minus 1, right? And then minus 4 times 2 is minus 8 plus 1 is minus 7. Then minus 4 times 0 plus 0 is 0. So minus 4 plus 4, 0, minus 2 minus 1, minus 8 plus 1 minus 1. Listo. The next one is row 3. 2 row 1 plus row 3. Two minus 2 is 0. Minus 6 plus 7 is 1. 2 plus 2 is 4 plus 9 is 13. Are you guys right or not? Are you guys following me or not? Man, if you guys don't talk, I'm gonna start making quizzes every day to see if people is paying attention. I don't like to talk to myself. So row 4 is what? So how do we gonna eliminate this guy?
We can add 3, sir.
So how do we do? So 3 times what?
Row 1 plus row 4.
Plus row 4, thank you. So then we go 3 times 1 is 3 plus minus 3 is 0. Then 3 times minus 3 is minus 9 plus 7 is minus 2, right? And 3 times 2 is 6 minus 5 is 1. Oh, but I forgot. Oh, I forgot this one, but this one doesn't change, I think. 2 row 1 plus row 3. Yeah, I don't think there is any change because they are zeros. Yeah. Okay, now I like to change my row to positive just to make it standard. So let's make it now. Let's make here new row 2 is minus all row 2. So that's gonna be plus and plus, right? So I'm gonna use that one to get 0 here and 0 here. So I do. So the first one doesn't change. And now the second one doesn't change either because this is the pivot one. And then second one. So what should I do for my third row? My new row 3.
You're gonna turn 1 into 0.
Yeah, so how do I do that?
R3 times, let's see.
But row
1.
2, right? Because
You're
I'm
gonna
using the
subtract 1.
I'm using the row 2, right?
Yeah.
And I want to
Yeah,
use
you-
this. This is the pivot.
Yeah. It's 1 minus 1 times 1 is equal to 0.
Yeah. But how do I write it? So that'll be minus row 2 plus row 3, right?
Yes.
Because then it gets this minus, will be minus 1 plus 1 is 0. Then minus 7 plus 13 is 6. And then 0, right? And then for the next one, how do I eliminate this one? So row 4 is gonna be
Times 2.
times 2 times what?
Row 2.
Correct. Plus
Row 4.
row 4. Thank you, guys. So now it's gonna be 0 because 2 times 0 is 0, so it doesn't change. 2 times 1 is 2, plus minus 2 is 0. 2 times 7 is 14, plus 1 is 15. And 2 0 is 0. And now I guess I'm gonna I have to use this one, right? So I need to make that one. I had to make that one a 1. So I'm gonna, well, I guess, yeah, let's do like that. So I'm gonna, row 3, I'm gonna divide it by 6. So row 3 divided by row by 6. So I get 1 minus 3, 2, 0. I get 0, 1, 7, 0. And I get 0, 0, 1, 0, right? So that's my pivot. And well, let me make it 1 here then. 1. Let's put it like 1 here. So, and then, so I do 0, 0. So how do I make this one a 0?
Divide by 15.
So divide by 15, which row?
Oh, sorry. You said into a 0? No. Multiply row 2 times, row 3 times 15.
Negative 15, right?
Yeah, and subtract row 4.
Yeah. Well, yeah, that would be another way. Yeah, so I usually like to put the negative to this guy, and then add it. But yeah, there are different ways to do it. So that will be 0 and then 0 over here. So what do you guys think? Is linearly independent or not? Well, we don't know, right? So let's do it. So x1, x2, x3. So be careful with this. This could be, I think we just faced this mistake before. Oh, I made a mistake. So you have 3 columns, but you have 4 rows. And the 4th row is just 0. So it looks like infinitely many solutions, but it's not, because I only have 3 columns. So I need to do back substitution. So don't be too fast. So better always do back substitution so you don't lose points, okay? Too easy, too fast, too run, okay? So what are the questions? So tell me what are the questions, guys?
1x1 minus 3x2 plus 2x3 is equal to 0. And
Thank
then,
you. Yeah, keep going.
For the next one, it's going to be 1x2 plus 7x3 is equal to 0. And then the last one is 1x3 is equal to 0.
Good, thank you. So x3 is equals to 0, so I need to go back substitution over here. Then I get x2 plus 7 times 0 equals to 0. So what do I get? X2 equals?
It equals 0.
0, thank you. And now I put those two over here. So I got x1 minus 3 times x2, that is 0, plus 2x3, 0 equals 0. So we get x1 equals 0. So what is the conclusion, guys?
They're linear independent.
They are linearly independent. Thank you. So we got this equation, and the conclusion is x1, x2 equals x3. They're equals to 0. Therefore, linearly independent. Okay. So basically it means you have one vector here, and another vector here. So these two could be in one plane. And this one is outside of the plane. So they're linearly independent. If you have something like this, they wouldn't be linearly independent, okay? So questions? So you see that we had to do sometimes the bigger, but usually the examples are set up so it doesn't go that long. So let's do another example. So we have homogeneous, non-homogeneous. So I'm checking the book, and so the book is showing some of the statements already showed you in the slides. So there is a combination of the slides with the lecture, no? So the slides give you all the theorems and all the stuff, but it doesn't give you examples. So that's what we're doing now, examples. So I'm trying to find another nice example. Yeah, I think pretty much it's all that we wanted to do. So I don't find other nice examples. Let's see Wellwork. Let's see if Wellwork has something nice for us. So our sets. So let's say linear independence. Let's see these problems. So are the vectors linearly independent? If they're linearly independent, find scalars that they are not all zeros, as the equation below is true. Yeah. So we had to do just what we did, right? So make the system. So what is it? 4 minus, let me write it down. 4 minus 4, 5. 4 minus 5, 4, 2, 2 minus 3, minus 1, minus 5, 2. So let's do. So what we need to do It's just as we did. So we need to put 4 minus 5, 4, 2, 2 minus 3, minus 1, minus 5, 2, and then make it equals to 0. Okay. So this is x1, x2, x3. So what we're doing is checking if x1, u1 plus x2, u2 plus x3, u3 is equals to 0. So if we find x1, x2, x3 they must be 0, then it's linearly independent. Okay, so it's just what we did. Other very similar. Yeah, they are all the same. Are the vectors and linearly independent? So yeah, so you need, they give you these first 3 vectors and then the last one and see that they're linearly independent. So what you do is the same. You just put, as you see here, you have to find the scalars that will make it 0. Okay. So let's say if this one is u1, u2, u3, u4, you just set it up the same thing. You make it x1, u1 plus x2, u2 plus x3, u3 plus x4, u4, and make it equal to 0 and see if the x1, x2, x3, x4 are 0. Okay, so it's nothing special. This one, the vectors are linearly independent even if k is different than that. So that's not like the first question you make me today. You just do the same, but you need to carry the k. Just do the algebra with the k, and at the end, choose the value for k. So try it and let me know on Wednesday if you got any problem with that one. So you have different examples here. Which of the following sets of vectors are linearly independent? So I'm trying to think of a fast way to do this. Let's check it out. Let's see. Phone, yeah, no. I mean, letter B is dependent. Okay. Because, for example, you can put 5, 0, 0, and then plus 0 times minus 4 minus 9. That will give you the sum 0. So at least the first question is not going to be 0. So B is linearly dependent. The first one I would say is linearly independent. But you have to verify it, but I think that one is linearly independent. So one way to do is try to write the last vector as a combination of the other one, but sometimes oh yeah, letter C is easy. Can you see it? Can you do it in your head? Letter C. Why this one is linearly dependent? This is linearly dependent. What numbers would you put so it's linearly dependent? So I think the idea of this exercise is try to do it in your head. So for example, if you put on the first one minus, and then you put 1 on the second one, you will obtain the third one. Because minus 10 minus is 4, plus minus 8, you get minus 4. Minus 10 minus is 7, plus 4 is 11. And minus 2 times 9 minus 2 plus 9 is 7. So you see that's linearly dependent. So I think they probably want you to do this in your head. But, you know, if you cannot do it in your head, you just do the long way, okay? And the last one. If x equal is f x equal r plus 4ud, then well t equals I guess. This probably looks too complicated. Probably I will erase this one. Probably later we can do those when you get more confident. So let's see. Then well, the linear dependence and span. So let's see what is in this one. Final linearly independent set of vectors span the same through the space of R1 is R4 as that span by the vectors. This a linearly dependent spanning set for the subspace is. Oh yeah. So what we need to do here. So they're basically telling you that you just need 2 vectors. So you need to choose out of those 4, 2 vectors that are linearly independent. So you need to, out of those 4, you need to find 2 that are linearly independent. So that's what are they asking, okay? So you just choose one. Well, actually, when you do the 4 at the same time, you'll see which one you can eliminate. Yeah. Let's see another one. Have the same thing. Yeah, same. Find a basis of the given space by the leading linearly dependent vectors. So yeah, so here you have to eliminate the ones that are not helpful. And for example, 0, 0, this is an easy question because 0, 0, 0 doesn't help you at all. So I'll eliminate right away the 0, 0 because the 0, 0 doesn't provide anything. So I'll leave the other 3. So let's see. You see that the solution is just leave the other 3. You see 0, 0 doesn't help you anything. Number 4. So here you have to let's do this one. So we're gonna do this one and we're gonna find which one is not linearly independent. So we eliminate that one. Okay. So let's do so 1 minus 1, 1 minus 3, 3 minus 3, and 2, 7, and 8. Okay, so goes 1 minus 1, 1 minus 3, 3 minus 3, 2, 7, and 8, and then 0, 0, 0. So out of those 3 vectors, we only choose you're gonna choose 2. They're linearly independent. So, but I think you can know which one is bad. So let's say this is U1, U2, U3. You cannot, I don't think we need to do all the process. Which one will you choose, guys? Guys and ladies. Who will you choose? Second?
U2.
You will choose, U2 what? U2 is good or U2 is bad?
Bad.
U2 is bad. Why U2 is bad?
Because it's 3 minus 3 plus 3. I mean, minus 3.
Mhm.
-3 minus, yeah. Gives us a negative value.
No, but we wanna. So I want you to look at the three vectors, 1, 2, and 3, and two of them should look very similar to you, very similar. So they are basically in the same line. So you don't need the two of them. Only with one of them you have enough. So which one of these two are like brothers?
Oh, which two are related? U1 and U2 would be related because
Exactly.
they have.
Yeah. Because if you multiply times -3, the first one, 1 minus 1 and 1, you obtain -3, 3, and -3. So basically -3U1 equals U2. So these two guys are in the same line. So you don't want two guys in the same line. So you could choose this guy and this guy, or you could choose this guy and this guy. So either of the two. Okay. So let's try it. Let's try it to see. Well, I don't know if I can submit answers here. Oh no, let's put, let's see if it lets me. -3, then 3, then -3. And then put 2, 7, and 8. Yeah, that work. But let's say that we instead choose the first one. And we are saying that both work. 1, -1, and 1. You see, that one worked too. So you just choose one of the two. Okay, they're linearly independent. I think that was the last. So you have to do the same thing with these ones. So I already told you this one, no? The 3 now is, the zeros is bad. Here, maybe it's not that clear, this one. Probably this one you have to do the whole thing. 3 minus 3, 3 minus 4. Yeah. But you know what? I can give you some clue. For example, yeah, if you look at those, which one out of two? Which one out of these four look close to each other, like brothers? Which of these two look more like brothers than the two others?
U1, U2, U3,
They look like what?
like each other.
U1, U2, U3. I don't know if I don't know. I just give me two. Give me two. The two that looks really like. Oh, give me two that definitely don't. They really look independent. Give me two that really look independent.
U4 and U3.
Well, I mean, probably we all have different eyes. So, for example, I will choose the one, the first one, because that one has 0 on the first spot. So that one is already saying he has 0 on the x-axis. Okay, so that gives me some linear independence right there. And the last one, you see, has 0 on the second row and 0 on the last row. So the first one and the last one, they're really not related. Okay. they're really not related because I cannot obtain the first one out of the fourth one because I need a 0 on the first one and I have to multiply everything times 0. So no way I can get. So 1 and 4 are good. So I will just choose any of the other two. And I think that should work. Okay. So that's kind of how you can. This linearly independence is sometimes easier than you think. You don't have to do so much. So we can try. So 0, 0, 3, no, 0, 3, minus 2, then minus 2. So I try to save you time so you don't spend all the time doing those things. I mean, so you have intuition, right? So let's try minus 3, minus 3. Yeah, it looks good. Minus 3. Oh, shit. What is the other one? Yeah. So minus 3, 3, 3. But I think either way, one of the two in the middle would work. Minus 2. Minus 3, 3, 3, minus 2. And the other one is minus 3, 0, 5, 0. Ay. It didn't work. Your vectors are linearly dependent. Minus 3, minus 3. Ah, maybe there is a way to get those. Oh, I put it. How that can depend? So yeah, so it's not that easy. So let's maybe we have to then they have to choose the other one. So let's try the other one. 3, 3 minus 4 and minus 2 and then 2, right? But I mean it has to be right because otherwise there is no answer. What is that one? Yeah, so that one worked. So yeah, probably this one. Do you guys see it? Why the first three were linearly dependent and this one is not. Let's see. Minus 3. So I should have 1 for the first one. And then oh yeah. So look at this. If I choose 1 for U1 and 1 for U4, I will obtain U2. Because 0 plus minus 3 is minus 3. 3 plus 0 is 3. Minus 2 plus 5 is 3. And minus 2 plus 0 is minus 2. So if I add number 1 and number 4, I will obtain number 2. So that's why they're not linearly independent. So you guys see it? So yeah, so maybe you have to try to add it, maybe subtract them, and probably the problems are not gonna ask you more difficult than that. So you want to save some time. And so yeah, so homework is not that bad, right? Okay, so I think that's good enough. I think we go over your homework, so you can probably go over this very fast. So we can probably stop here, guys. So any questions? Could you go back down? Oh, sorry. You guys better talk to me because otherwise I don't see the chat. I don't get messages from this chat. And okay, yeah. Thank you guys when you guys answer. So we're gonna stop it here. So let me know. Do you have any more questions? No. So on Wednesday, we're gonna have face-to-face quiz, and I'm gonna give you the whole kind of the class to do your quiz, okay? For Monday, Wednesday class. And on Friday, I will meet with you on Friday. Probably the first part of the period, we will have the quiz. And then record. Okay, so if there are no questions, so we are leaving. Okay, have a nice day, guys. Thank you for attending.
Have a good day.
Have a good day.
Bye, guys. Thank you for helping on the class.